My name is Godwin Usobozi, and I will be taking you in Principle 425-1 Mathematics, which we term as pure mathematics. So our code is P425-1 pure mathematics. Pure mathematics. So it is a principal paper which has got two sections. So it comprises of two sections. We have got section A, which carries 40 marks and which consists of 8 attempts, each number carrying 5 marks. And as a student, you are supposed to attempt all. And when it comes section B consists of 7 questions, and you are supposed to attempt 5. Each question carries 12 marks, totaling to 60 marks. And for a learner to get a distinction, our distinction starts for a distinction 1 starts from 85 plus. So it means you need to work hand in hand in all sections and do the best. And when you are doing this paper, always start from section A. Don't always rush, start from section B. The total time is 3 hours. Time is 3 hours. So in those 3 hours, you are supposed to do all the questions. Section A, there are 8, and section B, you are supposed to add 5. So that's what moves on. So we are going to start with the first topic, which we are going to be moving on together. And our topic is termed as indices, logarithms, and surds. So this is the first topic which we are going to look at, and it goes indices, logarithms, and surds. And they are not new to all of you because you have learned them right from O level and you have been assessed with them. But now when it comes to this level, we are just advancing on them. We are adding on the more concepts in it. So we are going to start with indices. And what do we call indices? How do you tell somebody that these are indices? So in simple terms, an index is a number raised to any power. That's what we call an index. Can either be 2 power 3, 2 power negative 4, a power 1, a power 5. All those ones, any number which is being raised to any power, we term them to be indices. So we can say an index is a number raised to any power. So a power can be positive, can be what? Negative. So they are termed as integers. So that's in simple term when we talk about an index. An index is a number raised to any power. So any number can even say 10 power 5, 10 power negative 2, 10 power 0. All those ones are termed as indices. So for example, let's go ahead. For example, if A is having a power of 1, mathematically this can be written as A power 1, which is the same as A. So you can see that element of having a power, A power 1, is termed as an index or indices. So we are going to be building more and more on that. So As we are moving on, we can say that also note the following. Note the following. Number 1, if I say a power 3 times a power 2, we want to look at this. This is the same as what? A power 3 means a is appearing how many times? 3 times. So we can say a times a times again 2. When we talk about a squared, it means a squared is appearing how many times? 2 times. This is the same as a times a. So which is the same as, how many a's are here? 1, 2, 3, 4, 5. So this is the same as a to power 5. So this one becomes an index. A is an index, is an indice. So number 2, if I say a power 5 divided by a squared, this is the same as what? We're having a division. This is the same as, it means how many a's are here? There are 5 a's. So this is the same as a times a times a times a again times a. How many a's are here? There are 5 because that's the power. Divide, which means all over. How many a's are here? 2. A times a. So if I try to reduce, you can see mathematically a goes with a goes with a. How many a's have I remained with? I have remained with a power 3. So you can see these ones are developing us or are taking us to the laws of the indices. Similarly, if I have like a cubed power 2, what does it mean? It means already an index is appearing 2 times. How do I this one is the same as a power 3 again 2 a power 3, which is the same as, how many a's are here? There are 3 times. Again, how many a's are here? There are 3 times. So when you try to multiply them, we shall come out with a power 6. All these cases which I have been doing, they are now taking us to the laws of indices. So as learners, before we go on to know the laws of indices, we must know all these atoms, how they came from. So these ones, so the above results, you can say the above results are now taking us to the basic rules or laws of what? Indices. So that one is very, very important for you to note it there. So we can't just move on with indices when we don't know where they came from. So we are going to say that, you can say that the above results or the above cases, because we have given you 3 cases, you can say the above cases are taking us to the laws of indices. To the laws of indices. So we are going to look at now the basic laws of indices as our subheading. Basic laws of, that means we will first deal with the positive ones. You can even include and say positive laws of indices. So we want to look at these laws of indices. Before we proceed on doing all the numbers, the first step is you must know the laws which are governing us on these atoms. We can say that we can start with, we are going to be using these numbers. We can say provided A is not equal to 0, provided that A is not equal to 0, and that both N and M are positive integers, So we are going to look at when our A is not equal to 0, because when A is equal to 0 to the thing, the whole equation will be meaningless. So provided that A is not equal to 0 and that both N and M are positive integers, then the following laws are going to be implemented, are going to work. Number 1, if I have A power N times A power M, this is the same as what? This is the same as what? When we are multiplying numbers of the same base, consider base is A and another base is A, but we are having a multiplication sign and the powers are different. When the bases are the same and we are multiplying, what we do, we only add the powers. We maintain one base and we add the powers. So this becomes A power n plus m. So you can see that when we are multiplying numbers of the same base, we automatically add the powers when the bases are the same. But when you find that the bases are not the same, then you are supposed not to follow that rule. So that's the first attempt on it. So we are going to be developing more and more laws until we achieve the best.